Okay, here we go with the review of the Waves study guide. Two possible points, one for the front, one for the back. Those are extra credit points that actually can help you grade, obviously, since they're extra credit. So that, just wanted to touch on that real quick. Sorry, I made a mess. Okay then, let's take a look at in the picture on the right. Picture that you're looking at. In the picture on the right, blank, line A is showing the blank of the wave. So looking at line A here, you don't need to highlight it on your copy. It is showing wavelength. Okay. Line B, again, you don't need to highlight, just making sure we're all in the same place. That is showing the amplitude. Okay. Point D, bottom of the wave, it's going to be your trough, T-R-O-U-G-H. Point C, top of the wave, that is showing the crest. Okay, I'm going to go ahead and call these A, B, and C for the equations that corresponds to what you see on the Waves Snaps page. It says diagnostic, but this is actually, we're going to use the same one for those of you who do the quiz on Google Form. Those are the same diagrams that are on your quiz, so it's not really any secrets showing you that. So let's take a look here. If the wavelength is 8 meters and the frequency is 4 hertz, calculate the velocity. We want to remember that triangle thing. It's going to help us out. You're given the equations, so technically you don't need to remember them, but I think it can't hurt to have this on the page. So I am looking for velocity. That means that I would cover up my velocity. Tells me that I have wavelength times frequency. So the equation that I use, looking for velocity, frequency times wavelength, equation A. Okay, the work to solve the problem. 8 times 4 equals 32, and I'm looking for velocity, so it's going to be meters per second. Remember, this one's going to be meters per second. This one's going to be hertz. Oh, I'm sorry, that's wavelength. Frequency is going to be hertz. And wavelength is going to be meters. The answer with a unit, and it says that you could just highlight the unit. You could also circle the unit, whatever you're comfortable with. I'm using a highlighter just because it stands out then in the background. Velocity of the wave is 48. The frequency is 8 hertz. Calculate the wavelength. So this time we're calculating the wavelength. That means we're going to cover up this corner. Now we're looking for V divided by F. That tells us that we're on this equation here. Get this sticky note out of the way. Okay, equation that I used. Wavelength equals velocity divided by frequency. Equation B. Okay? My work to solve the problem. We're looking at division. 48 divided by 6. Hopefully that one should stand out to you. The answer is going to be 8. 8, and then with a unit, we are looking for wavelength. We know that wavelength is measured in meters. It's going to be 8 meters. Okay, which wave demonstrates the higher frequency and why? So for this one, you actually have to explain. Higher frequency is going to be B. B has a higher frequency So there's your half point. This is, on the study guide, it's just 2 points flat out. Did you do the front? Did you do the back? But on your test, half point for correct answer. B has the higher frequency, half point. And why? Because the wavelengths are shorter, period. So, capital letter, period, complete sentence, that's the other half a point. Giving a full explanation, that's going to get you your full points. That's side 1. Side 2, how does changing the state of matter of a medium affect the speed of sound through that medium? Sound moves slowest, should know this, through a, and for when we're watching it in class, hopefully you're shouting out, and fastest through a solid. And I'm going to give more detail because more detail on the test actually counts for, proper points. This is because particles in a solid are more closely packed. Okay. During the frog croak demonstration shown below, in which medium will we hear the frog quickest? Explain the reason for your answer. I know it's a little tricky to tell with these black and white pictures, but this guy is outside, and this guy is underwater. The underwater guy will hear quickest because sound travels faster in a liquid than a gas. Okay? States of matter are solid, liquid, and gas, but not necessarily in that order. Just using the data below, which speed most likely represents mechanical energy wave traveling through gas. What evidence do you have to support your statement? Okay, I'm gonna write in the answer here and then explain it. It's just tricky for me to write and hold the camera at the same time, so just 1 second. Okay, number 1, 344 meters per second most likely represents a wave traveling in a gas because the molecules in a gas are spread out, making waves travel slower. So complete sentence uses the actual information that's here, gives evidence and reasoning supported by what we talk about in class. What kind of wave travels through the ground and is responsible for earthquakes? We mentioned this once or twice, not a lot. You should know it hopefully from 6th grade when you talked about earthquakes. It's going to be seismic waves, so it's going to be B. And that is your study guide. Best of luck on your test.